thank you all so much for coming. I think Benno is a man who needs very little introduction, but I'll try. This is Benno Augustinus. He is a scientist here, postdoc here at WSL. Benno did his bachelor's and his master's in Wageningen, and then he moved to Delavant in Switzerland for his PhD, which he did joint across Kabi and the University of Fribourg. He's been at WSL since 2020 in the Forest Health and Biotic Interaction Group, where he's modeling the priority quarantine pests. And today he's going to be talking about his urban tree database that he's been assembling as part of this work. So please welcome Benno. Thank you so much for coming.
Thanks, Debbie. Yeah, it's funny because when I came here, I didn't know I would be working with urban trees. But I really started enjoying it, and it's really cool when I now walk through a city that I look around me and go, oh, that's a cool tree, and wonder what it is. It's not a native. So I really think also that urban trees make cities just prettier. But
yeah, click and then
yeah. But urban trees also have quite some different function except making cities prettier. They remove a lot of fine matter and increase air quality. They help with water management in cities, and especially with torrential rainfalls, which will be more and more important with the changing climate. And since we're talking about changing climates, they also have a lot of other effects. They have the shading effect. It's just nicer under a tree in summer, right? And they also actively cool the air through evaporation, right? There are.
Sorry, just to share everyone in the
in
the Zoom there.
So there are also other positive effects than being trees. They assimilate a lot of CO2, but there are also other people in Benno that just like how they look, and they influence the perception of trees. And last but not least, we are at the Biodiversity Seminar, and urban trees also do have a positive effect on biodiversity, we would hope.
sorry, Benno, the screen, they can't see your slideshow. There we go. Let's try now.
No worries. Can you give me a thumbs up if this works?
Just carry on.
All right.
What you can do is you can share your screen with the presentation.
Now, as I said, I wasn't originally focusing on urban trees here. I am actually just finishing off a project where I use bioeconomic models to optimize the surveillance scheme for priority quarantine pests in Switzerland. It's a mouthful. And we have this big model, and urban trees are just a small part of it, but a very important one. Because most first detections of invasive forest pests are actually in urban areas. For that, we went to look how the data availability for urban trees is in Switzerland. We found this paper which is a global urban tree inventory. It's just a collection of a lot of tree inventories all over the world. There are 70 urban tree inventories for Europe, but just only 4 for Switzerland. And as we know, Switzerland has a bit more than 4 municipalities. So we decided that we wanted to have a bit more data about this. So we basically decided to make an urban tree inventory for Switzerland, which it means just calling and mailing a lot of municipalities, harassing them, asking them whether they have urban tree inventories and whether they would share them with us. And a lot of them did. We have now some 26 datasets that I combined in this presentation. They come in all different shapes and sizes and with all the different coordinate systems. I always wondered whether we really need 3 or 4 of them in Switzerland, but okay. They come in different languages and they are just very different. So putting them together was actually more work than you would think. But in the end, I got one database together and I determined the genus and species of these given trees, because there were also quite some typos and there are some language differences. And I could clean that up quite nicely with the GBIF backbone, with the fuzzy search. And that gives us a total of just shy of 500,000 trees, with 131 genera and more than 1,500 species. So I was thrilled about that, but then we started looking into our data, right? And the first thing we did is look at spatial autocorrelation. And to our surprise, there was no clear sign of spatial autocorrelation. That means that cities that are closer by don't have a more similar species tree distribution. So that was a surprise, because we would think that closer cities would have similar urban tree data set, but it's not the way. But what is interesting, and I know this is simplified, is that language spoken in a region actually explains difference between their species composition. So there must be some kind of cultural background in how these trees are planted. Obviously, people that care for these trees go to different schools, if it's French speaking or German or Italian speaking. And that might be an effect, but there might actually be a real effect of culture. Of course, right? We have Ticino in there and everybody goes like, yeah, temperature there is different from here. Everybody has gone there for nice weather at least once. But the interesting part is that the difference between German and French-speaking regions is statistically significant, and I found that quite interesting. We put this in an MDS, it's not that clear, but it tells us already that there is quite a difference. We have the purple ones, which are the Italian speaking points, the magenta ones, the French-speaking ones, the red ones, German-speaking areas, and the green are the E-line. And you see there is quite some overlap, but there are also some differences. And for example, no big surprises. The genera that describe the tree compositions in Italian-speaking places that define the most are subtropical species like citrus, olea, or cinnamon. But then when you look at our urban trees, we have a bit of a problem here, because the most urban tree databases only show complete inventories, but only from the trees that are in cities' care. So we don't know what people were planting in the gardens, and that is like a big hole, because these trees planted in gardens make up a large part of the number of trees in our cities. But here we get some exceptional databases, and that's, I think, not only in Switzerland but also like worldwide. We have Lausanne also has this to a certain point, but for Geneva we have a great data set where you, on the homepage of this of the canton of Geneva, you can actually click on trees in your garden and say which species there are. And a lot of people did that. So we have the database of Geneva is great, because it is almost 250,000 of trees, right? And about half of them are private trees. So we have some information about how these species composition is there. And when you do a pair maneuver on genus level, we see that there's no statistical difference between private and non-private trees. We were super surprised to learn this, but for us it's also great, because in a way, and that I know it's a big assumption, but we assume that our tree species, at least on a genus level, are representative for what is in the whole city, if we have city databases. It's a bit of a stretch, but I mean, it's better than nothing, and it gives us quite something to work with, right? Now, we want to learn more about this, and Sarina has just started a master thesis on this, and she will explore this more. She will also talk to tree nurseries and get on the ground of these things. She is here since 2 weeks, and she will be here until April, so be sure to hear from her then. If we now look at our urban tree data set, I mean, it sounds spectacular, right? 1,500 species, or it doesn't, depends where you're from. right? If you're from South Africa, there are 4,000 native species developed. But for us, it's actually a big deal. And to really show that, I want to compare urban and forest trees surrounding these urban areas. So for that, around all my municipalities, I drew a circle of 10 kilometers with a 10-kilometer radius. And then I selected all the NFI plots in there. That's the plots from the National Forest Inventory. That's a very cool project here at WSL, very big, where they sample these plots every 5 years and give us a really good inventory of what is in the Swiss forest and what is happening, right? So I drew the circles, and from now, several of the next slides will deal with these comparisons, right? I'd like to go along these two questions, like first of how different are these three data sets if you compare them, genus and species composition. And then I'm also interested because, well, forest health and interactions, what are the implications for urban and surrounding forest health? And I focus on invasive species here, so on quarantine species. So if we compare them, we get, and with a rarefaction analysis, we get this. And a rarefaction analysis, I guess you know, but it compares the species richness of different groups. And it tells us also something whether the sample size that we take from our groups is big enough to really cover all the species in our groups. And it already gets quite spectacularly different between genus, and it's even more different between species richness in between the forest and the urban data sets. We also see that the forest data sets are really nicely covered with the sample size, and for really get everything of your city species and genera, you really need high sample sizes, and we're happy that we have a lot of trees in our data set. What's also interesting is that forest tree composition and urban tree composition is described by very different species genera. So you really see how these NMDS are really nicely separated. There's no overlap whatsoever. And that's also interesting to see that they are really different, right? So the next step for me was to look into whether one is a subset of another. So these are Euler plots. They're basically Venn diagrams, but true to size within every circle, every municipality. And we see that in most cases, the forest trees, at least the genera of the forest trees, are subsets of the genera in urban tree data sets, except when they're not. But to understand what's happening here, we should also look at some that are really nice subsets and then compare the two. And here the point is just what I made earlier. We're talking about very small data sets compared to what we have in Zurich and Geneva. We're talking about 700 and 400 against 70,000 and 130,000 city trees. So they are on very different places on this rarefaction curve, and that would actually, together with our knowledge, our assumption that private trees are also kind of described by urban trees, say that our trends still hold up, and we can really say that, or we can assume that that these are subsets, and that means they are representative of forest trees and urban data sets, but not the other way around. Now, if we look at species richness, we also should look at frequency. And this is not a nice analysis, this is just putting two lists next to each other. But we can already learn a lot from this, right? This is all tree species that make up more than 1% of the data sets, of the originating data sets. And we see already quite a difference, right? One is longer than the other, right? But we also see that Picea and beech make up almost 50% of all trees surrounding our municipalities. When we look at the percentages in the urban trees, that's much lower. So the frequency of these different species, even the most common ones, is much lower. Right? We also see that all trees in the forest, as you would hope, are natives, at least the most common ones. And you would expect this to be quite different for urban trees. I just see I should excuse myself for all colorblind people. I'm sorry, I did not think this through. Anyway, what we see is that that's actually the most of the urban trees, or of the most common urban trees, are actually natives, right? With a few exceptions. We're talking horse chestnuts, obviously, plane trees, Robinia. But there are also some more dodgy cases where we have to take into consideration whether we can really call them native trees. When we just not look at Pinus niger as well, that's a whole different discussion. But also we have domesticated apple, plums, pears that are very common in urban trees, tree data sets. And are there really native species? It's a bit tricky. And then you have all these funky hybrids that just don't exist in the nature. So, but overall, we see that there is quite a lot of native species in Swiss urban tree data sets. It's a bit surprising, but it's also interesting to see. It's good for biodiversity, you would guess, but it also means that there are great stepping stones again for the surrounding forest for secondary infections, right? So, to dig into this a bit more deeper, I went to the Apple A1 list. Apple A1 list is a list of 200 pests. It also includes non-forest pests, but bear with me. And these are not present in the Apple region yet. So, but these could be invasive and people are worried about them. And then I just compared the fraction of host trees in Swiss cities with the fraction of host trees in surrounding forests, right? And this is, like all the slides before actually, very much work in process, but if I get the chance to show someone a violin plot, I will take it. This shows us some things. This is basically a box plot, but then it shows you the distribution of your data as well. I think they're beautiful. What we see here is that we have highly zero-inflated data. We really have a lot of zeros. Especially in the forest, we get much more even than in the urban data sets. But at the same time, we have a much more variation. So we have there is some pests where all forest trees are suitable hosts. And it's pretty nice, right? If you think about it. And this distribution is a bit higher. And that, in the end, returns basically the same mean. Even if there's, a bit of a statistical difference, it's basically the same. But then if you make a GLM with the interaction between the environment and the pest, you see that this interaction effect is significant for a whole lot of pests, which basically tells us that the pests preferring forest trees are not the pests that are preferring urban trees. So with that in mind, we see that in total has an additive effect on the suitability for a pest that gets introduced here. Right. And then if we zoom into this, let's just take one pest. I chose this little bug, the emerald ash borer. As you might have noticed, the ash trees in Europe are not the happiest. And I think ash in general has not such great years in the last times, globally speaking, because in the US it's even worse, right? Where there's green ash and there's emerald ash borer, you have almost 100% tree mortality. And that's a big issue there. And also, if this is news to you, oh God. So emerald ash borer has arrived in Europe. We already have it in Russia here. There are confirmed sightings in Ukraine, and since that is not a great place. it's at the moment not terribly well controlled, we can expect this beetle to come our way anytime soon. So what does that mean? If we look just into our urban tree data sets, we see that almost every urban tree data set that we have, I think the only one that doesn't have ash trees in my data sets is Ruhr, right? All these data sets have ash trees. So that should make some people nervous because you have to find replacements for these trees. And then if we zoom in further, we see look at the spatial distribution, and that's something I wanted to just illustrate with this case. If we go to the Dufourstraße in Zurich, here, it's a beautiful street, looks beautiful, it's all green ash. That's a very much a preferred host of emerald ash borer, and it's more than 1.5 kilometers long. So this beetle arrives at one end of this street and it can just go through. And this spatial distribution is quite different to what we find in forests. So that is something you should investigate or think about when you think about the risk of pests in coming into our cities. And we see that there are quite a lot of these alleys with ash trees along them, but there are also some scattered places. So in principle, yeah, it would be for emerald ash borer, this would be a very great place to arrive. Don't want to jinx anything, but so what are the implications? So a bit of a summary from what I've been telling you or rambling about for the last few minutes is that there is a higher species richness and a lower species frequency in urban trees than in forest trees surrounding these places. At the same time, there is a similar fraction of potential host trees, but this fraction of host trees differs in between pests. So we have some additive effect. Overall, we have a higher suitability due to that diversity between the different environments. I also think if a novel pest arrives in a city, it will probably find a host. For our priority quarantine to pests, I can tell you that in every city there are host trees for all priority quarantine pests of the forests. So that is something what means that urban trees are great stepping stones for invasive forest pests, and not only because that is where everything arrives for the first time, not because every movement happens there, not only because these trees are stressed because they are in a city, but also because they're there, right? And that also means that this is where we should monitor for invasive forest pests. And this has been like a hobby. This has been a hobby horse for me for the last 1.5, 2 years. I've been always saying that we should sample in cities, not in forests. So implications for you. What do I want to tell you with this, right? Basically, I want to tell you, first of all, this data set exists. It's a pretty cool data set, even if I think it myself. I really felt like I accidentally fell over treasure grove when I put everything together. We've got a lot of municipalities. We also have data sets of smaller municipalities, which is not very normal for urban tree data sets. So that is pretty nice. And then on top of that, most of this data is open access, or I had quite some of these municipalities agreeing with me the other day that they agreed to share it, and I will ask the other ones that haven't answered yet. So I can share this kind of data with you. There are also some really cool things that I haven't even gone into, where there are some of these data sets have planting data for trees. So we know how old every tree in that city is. Most of them are georeferenced. We have DBH measurement, we have health stages, we have pretty cool data there. Basically, if you want to take anything with you from this talk, is that there's a pretty cool data set here. I'm happy to collaborate. So if you have specific questions about this, just let me know. There are a lot of opportunities in this. Of course, we are thinking about using urban trees as expatria sentinel trees, where we sample, for example, North American trees for native pests, and then use that to inform blacklist for North America.
so that management there is improved. Or you use them as in patria sentinel trees, where you look at native trees and use them as early warning systems for here if you find invasive pests on them. And I've been talking about it before. But they are also kind of like common gardens. They can tell us much more about the future of our trees themselves, right? Within our country, we can examine tree performance, and I think Paolo Cherubini has done some quite cool work with that, with just looking at fitness and growth of urban trees. But you can also look at cities in climatic zones, which you think your city's climatic zone will move to. And with that in mind, but also with some other questions in mind, I will also work on assembling a European tree inventory that has a higher resolution than the global tree inventory that's known from 2 years ago. With that, I want to thank all these municipalities for sharing their data and being just, very friendly and easy to communicate with. And of course, I want to thank Eki, Valentin, and Meinrad for helping me getting this stuff done.
Thank you so much, Benno. So we have plenty of time for questions. So I think we'll start in the rooms to give the people on chat the time to type. So does anyone have any questions for Benno? Felix, yeah.
Do I have to move closer?
No, you're
Sorry.
fine.
No. So what would your suggestion be in terms of planting strategies? What species would you plant? Would you go for much more exotic stuff or only local provenances or species?
I really don't have a good answer for that.
Neither have I.
Yeah, no, I think that's a terribly complex question, and I think if you ask me, you will get a very different answer than if you ask someone who works with physiology of the trees. Which trees will actually be able to survive this? And you will also have a very different answer from the people that do landscape architecture. I read a report the other day about the city trees of Lamberswil. Right? There are terms in there I've never seen. They talk about this tree looks professional. So if you want to look your neighborhood professional, you should plant this tree. But if you want your neighborhood to be playful, you should plant this one. So I think it's a very complex question, and it should be addressed from as many as possible angles. Things where I think would be great to think about is how you deal with like genetic diversity, how you deal with spatial distribution of these trees. Many of these lane trees, they are genetic clones, right? So because they grow at the same rate. So if you already in lanes could increase diversity, not only genetically, but maybe even using different species, and you can live with different trees growing differently, you might actually win a lot of time. So
do you think, like for example, the horse chestnut, there's this minor moth or something that attacks it. Do you think that had like an avenue to go through Switzerland just because it was planted one after the other, or is anything known about that?
Not about
plantains.
Chestnuts. I know a colleague in Lisbon just did a really cool study about this, and he worked with. He had a demographic model that of citrus pest that used movement. It was a spatial including demographic model, and he just looked into how fast this insect spread, and he simulated that without urban citrus trees and with citrus trees in urban areas, because everybody in Lisbon, everybody in Portugal has a citrus tree currently in their yard. So that really is a beautiful bridge from one citrus orchard to the other. And I would not be surprised if that's the same story for any other pest that just arrives in urban environment in any way.
But Perhaps I can answer because of horse chestnut. There was a talk in Lisbon too, but perhaps we were two different sections at the same time. Could be, but there was something from France where they tested dilution effects with increasing tree diversity, and it seemed to work for some few species. And I guess horse chestnut with the leaf miner, and there is a fungus too. It was working too, the dilution effect, and
just kind of slow down.
yeah, and you can mitigate the damages somehow. Yeah.
Any question?
Yeah, very related to Felix's question. Is there a strategy in the cities? What is the strategy? Probably you know now. Or is
Yeah,
who decides what to plant where?
So, yes and no. I mean, it depends on to which city you go.
Yeah.
There are some rules. There's the 10, 20, 30 rule where you go like not more than 10% of the same species, not more than 20% of the same genus, not more than 30% of the same family. That's a rule that has been widely accepted as being something what you should work to, which, I mean, it sounds a bit arbitrary, but at least you can remember it. But that rule is also not that old. It's, I think, from 97, something. So that's not that new. I think there is a lot of arbitrarily planted trees. And also, I mean, when you see this data set, you find the wildest things. So yeah, I think that at least not on a national level.
Ginkgo biloba train station. That's a good idea.
Yeah.
Okay, we have a couple of questions online. So Kevin Vega from ETH wants to, he's from ETH now, isn't he? Yeah. Well, he says, I found the language difference very cool. One question he wanted to ask is to look into the past and look at the distribution of urban biodiversity and tree cover versus income and other social inequality measures to look into green gentrification. Do you have any plans to include some of these social comparisons in the future?
I have not yet done anything with it, and I'm also not really planning to. I've got my hands full with.
But that could be something someone.
That's definitely, and people do it, huh?
Yeah.
There is shown that there is an effect of the wealthier people are, the more trees there are in the neighborhoods. But then, interesting are also the more non-native trees are in healthier neighborhood, wealthier neighborhoods. And then there is also an interesting part that where through diversification of cities, people are starting to value trees different. So with a cultural background, you can also see like that's the definition of the beautiful city tree changes with a changing culture in your city. That blew me away.
I'm just building on Kevin's question. So like the Duforstrasse, it's a clonal street of ash, but that's also known to be a very wealthy and expensive street in Zurich. Are there more of these kind of, so you're not looking, then you're not looking, I was going to say, are there more of these clonal strips?
I don't know if these are clonal. I know that most of these lime tree clusters, they are all clones.
Okay.
Because that's also very easy to reproduce. But
Okay.
Debbie, I have to object. That was not a wealthy neighborhood.
That's true. When they.
Because I lived there. No, but I mean, they were planted, I don't know, 60, 80 years ago. So it was different then.
But you know, I'd show you if like certain cultural, geopolitical backgrounds, like Benno was saying, prefer different types of things. So perhaps wealthier streets become wealthy because they have these big monocultures.
Yeah, but I think for certain you should respect the time lag.
Of course, yeah. So then Sandra asks, would it make sense in the view of pests and pathogens not to plant monocultures?
Oh yeah. No, but that's, I mean, you see that is in the US, they expect, that was pretty dramatic. They expect like 60 to 80% of all urban trees to die within the next 20 years because they basically planted elm and ash and maybe maple. So I mean, there are just city blocks that will be empty of trees in 10 years.
Any more questions in the room yet?
Are you still interested in the spatial autocorrelation of the things that you're looking? Because you started showing
Yeah, well, I did a short test with that, and that's about it. I'm interested in it, but at the moment I'm not planning to work on it directly.
Because what I was going to bug you a little bit is that the way that you analyzed it, it actually doesn't show you exactly the spatial autocorrelation of the variable that you're interested, because I think you did a Mantel test, right?
Yeah.
Yeah. So there are like more geographical analysis that you could do it. And actually you could break like at country level or city level into several classes of distance. So you could see like if your spatial autocorrelation actually is high when you consider like from 0 to 200 kilometers, from 200 to 500 and so on.
How low level can you go? Because that would be a really beautiful analysis also for like
Sea level, yeah.
Can you go to tree level?
You can, yeah. If you have a distance between trees, yes, you can.
Yeah, because these are georeference.
Yeah, you could.
That would be awesome. Yeah.
Any other questions from the room or online?
I have one question, probably naive one, but how big is the influence of natural selection in these trees? Or let's say in natural selection, so mortality, is it big? Or is everything we see here, what you analyze, just the result of planting? Or do we have changes in the composition of the species due to non-adaptedness or whatever?
So I don't know where, but I read that there are places in cities where the average age of a tree is 15 years. That they are 15 years long in the city before they die and need to be replaced. You could talk about natural selection there in a certain way. Right? That also depends on where it is. If it's just next to at the side of a building and next to a road that sees a lot of use, that might not be a great place for a tree. And then park trees can get very, very old, we know. So I think there is selection, but I wouldn't call it natural selection.
But compared to the plantings, you would say it's minor. Like if you're planted as a tree in the wrong climate, probably doesn't matter, I think, if you care for it.
Yeah, but the question is how much can you care for an urban tree, right? You have densified soil, you have a lot of salt in winter, so you have drought stress, you have heat stress in summer. Trees need to be really sturdy to survive a long time in a city.
Kathy?
Yeah, I guess it was just following up on that. So your hypothesis or the evidence suggests that pests survive in urban environments and then attack urban trees. But is it also that these trees are somehow weak or stressed that makes them even more susceptible? So is it a double whammy? So first we get there, okay, then there's spatial maybe out of correlation these lanes, and then the trees are stressed anyway, that this is sort of a perfect sort of
I think it definitely is. I mean, we know that so there are quite some studies along urbanization gradients, and you see that has effect on health of trees, but also on the communities living on the trees. And we have that information on really on leaf surface area, where they looked at the composition of bacteria on leaf surface on lime trees and how that changed along an urbanization gradient, and there was a huge difference. But we also have that on pathogens. The only thing that plays the other way around, of course, like trees in cities are not happy and not healthy. But then there is also always a critic that people go like, okay, people find the first insects in cities because they are there, right? There are more people to see an insect when it detects a tree in a city. So, but I've seen a really cool analysis about that the other day, and it has a huge effect. But then when the maps are actually of hotspots are actually reproduced, they still look exactly the same. It's still not the biggest effect.
You also expect the point of entry of the pest species to be in a densely populated area, because that's where things come in.
Yeah. Well,
and they don't go through forest.
It depends. I mean, I think in general we can say yes. In our models, when we go to my other life at WSL, in my models we use imports, and we have imports to postcode level because Switzerland, that's really impressive for as a data set. But then we also use population density because all these imports go to places. For example, ALB, Asian longhorn beetle, the most import of packaging wood, what we are interested in, are not going to Zurich itself. They are going to the Aargau, where you have a lot of stone importers. And they are not in big cities because it doesn't make any sense. They need to be close to ports. But then after that, where goods are going to redistributed, and that mostly goes to places where there are most people.
There's construction then.
Yeah.
Valentin?
I have perhaps a more political remark and question that it's like urban trees they were like not very well studied. There is not an institute really focusing on urban trees or urban greens. At the basic, you have the WSL for forests and landscapes. You have the agroscope for the agriculture side, and there is like a gap that you started to fill somehow with these urban trees in Switzerland. But how do you have ideas how to raise awareness about these questions? Because I have the impression in the cities they mostly plant the trees by chance or by previous experiments that they made in their own cities. But how could we increase this awareness about these threats?
I mean, you're right. In some cities, I totally agree with you. In other cities, like in Zurich, they are really actively looking into what they're going to plant, and I think about it beforehand. The problem is, you start doing this now. We're talking about trees, but things live long. So I think the first part would be managing tree health, but then finding a good way to replace the trees that you have to replace. It's a question, and I think it's a legitimate question of focus of WSL, because if you think about like 80% of the people live or will live in urban areas in the future, and that is also something we shouldn't neglect in terms of potential for biodiversity and urban trees. So yeah, I think there might be a role to do more with that with WSL. But there is also going to be a meeting with people that work with urban trees in January. So I think there's things happening.
Through the Biodiversity Center.
That's the urban.
Murtaza, yeah, you had a quick question?
I had a very trivial question. So you talked about the trees that were going to be standing skeletons in 10 years, basically in the urban areas. You said that they had planted species that were ash and the other one. So I wanted to ask, like, if we're going to be planting like different species in those areas, wouldn't the tree systems of the older trees be already there and prevent like the future planting of other trees and disrupt some other dynamic?
You mean like the
Like the trees have roots.
Yeah.
They would be inside the urban areas.
Yeah.
So then planting a new tree there or taking those out, wouldn't it cause other problems as well? I just wanted to know if that's also being worked on.
I don't know. That is really tree physiology stuff that I'm not.
I think that trees on streets tend to have a very
Shallow root.
artificially constrained root system, because they don't want them to grow into the pipes, right? Because they do manage to replace trees on streets successfully, but you are right. Like Benno says, the soil in urban areas is suboptimal for such organisms. Basically, it's too constrained and tightly packed.
Yeah.
So I had a quick question for you, and then I think we can let him have a break. Some of the trees that you have in urban environments are known to be declining in forests, like Texas.
Yeah.
Do you see like reservoirs of species diversity of species that are being lost from forests that could indicate maybe genetic diversity that's being lost from regions, or?
Yeah, I don't know, because if you look at climate change in forests, that is probably our biggest concern when it comes to losing tree species at the moment. I think cities have also climate change, but it's on steroids, right?
Yeah, it's much faster.
I think so. You will have more. I think refuge for trees in cities would only work if they are trees that particularly like hot summers and dry winters.
Okay.
So I think the overlap there is rather small.
Okay.
That would be cool.
Okay, everyone. So please join me in thanking Benno again. And